So let us discuss about demand paging. So I'm going to explain this demand paging with respect to the following block diagram. In this block diagram, totally we have three components. The first is hard disk, next RAM, followed by CPU. Inside hard disk, I have a process called P, and this process P has been divided into totally 6 pages. It begins from page called 0 and goes up to 5, right? So with respect to this example, I have divided process P into 6 pages, right? Next, I have a RAM, and this RAM has been divided into frames. So right now, with respect to this example, I have divided this RAM into totally 9 frames, right? That is 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Now, generally, whenever a CPU wants to execute a process called P, we are going to move the entire process into RAM. So once the entire process has been moved inside the RAM, so then CPU is going to execute the process. So that's what generally we have seen. But right now, with respect to demand paging, we are going to divide a process P into a set of pages or a sequence of pages, right? Now, CPU, in order to execute a process called P, it's going to request a page of corresponding process, right? If that page is not present inside the RAM, then that page needs to be moved from hard disk to RAM, right? For example, let us assume that CPU wants to execute a process called P. Now, in order to execute a process called P, it's going to request a page number called 0. Since page number 0 is not present inside the RAM, so this page number 0 needs to be moved from hard disk to RAM. So once page number 0 has been moved from hard disk to RAM, our RAM looks like this. Yes. So once page number 0 has been moved inside the RAM, the CPU is going to execute an instruction which is present in the page number called 0. So once it finishes executing an instruction present in page number 0, it is going to request the next page of process called P, right? So for example, let us assume the next page is nothing but page 1. Now CPU is requesting page 1, and that page 1 is not present inside the RAM. So since page 1 is not present inside the RAM, we are going to move page 1 from hard disk to RAM. So once we move page 1 from hard disk to RAM, our RAM looks like this. So once CPU executes an instruction inside this page 1, CPU is going to request the next page of process P, and the next page is nothing but it is page number 2. Since page number 2 is not present inside the RAM, this page number 2 we are going to move from hard disk to RAM. So once we move page number 2 from hard disk to RAM, our RAM looks like this. So like this, we are going to move a pages from hard disk to RAM only if CPU is requesting for that page. So we call this behavior as demand paging. So that's what I have written here. Bringing a page into memory only when it is needed, right? So if CPU needs a corresponding page, so then only we are going to bring that page into RAM. Otherwise, we are not going to bring that page inside the RAM, right? So moving a page from hard disk to RAM when it is required, it is done by lazy swapper, right? So that's what it has said. Lazy swapper never swaps a page into memory unless the page will be needed. Swapping is nothing but we are trying to move a page from hard disk to RAM, right? But using the word swapping is not correct. So generally we use swapping whenever we are trying to move the entire process into the RAM. But right now we are not moving the entire process into RAM, but just we are trying to move only a a page of a process inside the RAM. So since we are moving the page of a process inside the RAM, instead of using swapper, we are going to use the word called pager, right? So that's what it has been written. I hope you understood this is demand paging. Thanks for watching. Thank you.